Welcome you all in the lecture series of Detailed Electronics KE 039/049, myself Dr. Kishanu Kundu, and from today's onwards we are going to start sequential circuits. Till now we have completed all combination circuit lectures. Now we are going to study a sequential circuit. Okay. So, in the today's lecture we are going to discuss about sequential circuit basics, latches and SR flip flop. So, let us begin. So, there the table of content we will be going to discuss the concept of sequential circuits, clock and triggering concept, latches and lastly SR flip flop. So, already in the previous lectures we have discussed about combination circuit. So, combination circuit is nothing but the present output depends on present input, okay. But the sequential circuit is present output not only depends on present input, but also previous output. This is the very important concept that sequential circuits not only depends on present input, but also the previous output, and to remember the previous output we need memory. So, memory concept is there, right. So, we can say that sequential circuit is nothing but a combination of combination circuit as well as memory. Got it? Sequential circuit is nothing but combination of combinational circuit and combinational circuit plus memory. It is nothing but sequential circuit. This is the very important feature of sequential circuit. So, next, what are the difference? Already I have told that output depends on present input in case of combination circuit. For sequential circuit, output depend on both present input and present state. You can say as past output. Feedback is not present, but in sequential circuits feedback path is present. Memory element are not required in combination circuit. For sequential circuit we are having memory elements. Here clock is not required, for sequential clocks it is required. It is easy to design and it is difficult to design, because more things we are going to add. We are going to add clock, we are going to add feedback. So, the design is little bit complex. Okay. Next, for the types of sequential circuits, there are two types of sequential circuits, asynchronous sequential circuit and synchronous sequential circuit. So, what is the definition of asynchronous? If some of or all the outputs of the sequential circuit do not change with respect to the active transition of clock signal, then that sequential circuit is called asynchronous sequential circuit. And if all the outputs of a sequential circuit change with respect to the active transition of the clock signal, then the sequential circuit is known as synchronous sequential circuit. Okay. Now, here we have discussed one term as clock. So, now we will discuss more about clock. So, clock signal is particular type of a signal that oscillates between a high to low state. This is low, this is high, again low, again high. So, it is oscillating between low and high, and here I have written 0 and 5 volt. So, in binary nothing is 0, 5 is not there, this is only two states 0 and 1, but this is correspondingly 5 volt means high voltage, right. So, 0 and 1, it is oscillating between 0 and 1. So, the what is clock period? Here one very important term we will be having, what is clock period? Clock period or cycle time Tc is the time between the rising edge of a repetitive clock signal and see, this is the rising edge and this is the second rising edge. So, this difference is called clock period, the difference between the two successive rising period, okay. And the reciprocal of this time period is called frequency, means this is T. So, f will be 1 by T, the reciprocal of this time period will be frequency of the clock signal, and mostly it is in the megahertz, okay, or gigahertz, right. So, next we will be discussing about triggering. So, there are level of triggering, positive level triggering and negative level triggering, and that will be second type edge triggering. So, what is level and edge? From this diagram I can say, see these are the edges, this is rising edge, this is rising edge and this is falling edge. So, these are the edges and this is level, this is high level or this is low level, this is low level, this is high level and this is the rising edge, this is the falling edge, again this is the rising edge, this is the falling edge. So, in terms of this we are classifying triggering and there are two types of triggering, one is level triggering and second one is edge triggering. So, there are two level, positive and negative or high or low. So, this is called positive level triggering and negative level triggering, and again we are having this is positive edge means rising edge triggering and negative means falling edge triggering. Okay. So, these are the classification of triggering. You can see from this diagram itself, see this is the high level, this is low level, this is low. So, if the sequential circuit is operated with the clock signal when it is in the logic high, then that type of triggering is known as positive level triggering. Next, if the sequential circuit is operated with the clock signal when it is logic low, then that type of triggering is known as negative level triggering. See here the low level, already I have highlighted. See when the triggering is done for the high level it is called positive level triggering, and when it is for low level it is called negative level triggering or falling level triggering. Okay. Next, if the sequence, this is the rising edge high, it is going to 0 to 1, 0 to 1, the transition is from 0 to 1 and this is from 1 to 0, see falling edge 1 to 0. So, right this we are classifying two things, one is positive edge triggering and second one is negative. You can name it as rising edge and this is falling edge, rising edge and falling edge. Okay. So, see if the sequential circuit is operated with the clock signal that is transitioning from logic low to logic high, then that type of triggering is known as positive edge triggering, and if it is from high to low then it is called negative edge triggering. This triggering concept is very important. Now, based on now we are going to discuss about memory elements, latches, flip flops. So, basic sequential circuit is latch, very basic sequential circuit is latch. So, latches operate with enable signal which is level sensitive, whereas flip flops are edge sensitive. Okay. These are the some basic comparison. It follows level triggering, it utilizes edge triggering approach, it is depending on logic gates, this is latches with the clock signal is absent. The basic difference of latch and flip flop is no clock signal is present in latches. We will design a latch and we will discuss it more. So, it is sensitive to the applied input signal when enabled, sensitive to applied signal with the clock signal. See clock signal is having very effect on this. Okay. Then power requirement is less, here power requirement is more, operating speed is fast, this comparatively slow, and type of operation performed asynchronous and synchronous. So, this is the basic difference between latches and flip flops. So, first of all we will discuss about latch. What is latch? Latches are the sequential logic circuit that are designed using logic gates and are used to store binary information. This is a storage element. Okay. These are level triggered, thus operate when they are enabled. These are also known as bistable multivibrator because of having two stable states. Okay. It operates in a way when the enable pin is active, every time with the change in the input the output gets changed. This means the change in input the stored information also changes. So, latches can be designed using universal gates either using NAND gate or using NOR gate. So, here in this diagram we are using NAND gate, we can draw it using NOR gate also like that. Second one, this is second one like this. Okay. And there are two state set and reset. So, for that reason they are known as set RSSR latch, set and reset, Okay. Set means 1 and reset means 0. So, that's why it is known as set reset latch, SR latch. Okay. It can be done using only NOR gates or only AND gates. Okay. Two inputs R and S, here also two input S and R, two output Q and Q bar. Okay. So, now let us discuss in detail about SR latch. So, we will draw a diagram again. This is one NOR gate, second NOR gate, this is the output and this is this. So, this is R and this is S and this is Q and Q bar. Okay. We are going to discuss about SR latch. So, what is the basic truth table of NOR gate? First of all, we will see the basic truth table of NOR gate. So, NOR gate A, B and Y, if two inputs 0, 0, 0, 1, 1, 0 and 1, 1. So, for NOR gate we can see that this is the truth table. So, the main important point from this we can check that if any one input is 1, the output will be 0, means in between A and B, if any of the inputs are high, the output will be 0, and this is the basic very important concept of SR latch. So, we can write that if any one input is high, then the output will be low. This is the basic main important characteristic of NOR gate, and this characteristic we are going to use in SR latch. The functioning of SR latch is purely dependent on this rule. Okay. So, again we are having two inputs and two outputs. So, we are writing that S and R and two outputs Q and Q bar. Okay. So, if we are having two inputs, we are having 4 combination 0, 0, 0, 1, 1, 0 and 1, 1. Okay. So, now I am taking, suppose first condition is this, you will be saying why sir, why not 0, 0, we will come to later to this. First of all, we are taking S is equal to 0 and R is equal to 1. So, if S is equal to 0 and R is equal to 1, so from the concept of SR here NOR gate, we can check that if any of the input is 1, the output will be 0. If any of the input is 1 of NOR gate, the output will be 0. So, here R is equal to 1. So, this input we do not need to check what is either 0 or 1, does not matter. If any of the input is 1, the output of the NOR gate will be 0. So, it will be 0, Q will be 0, and if it is 0, then 0 will be coming to this 0, 0 NOR gate, output is 1. So, we will be getting output as Q bar is 1. So, this is the first case, clear. Now, we will be checking as second case, where second case we will be checking as, now S will be 1 and R will be 0, S will be 1 and R will be 0. So, S will be 1 and R 0. Again we can check that if any of the input is 1, the output will be 0. From the NOR gate truth table it is clear to us. So, here 1 S is 1. So, we need not to check what is the second input, directly we can write Q bar as 0, and if Q bar is 0, this 0 is coming to here. So, 0, 0 NOR gate output is 1. So, see now this time we are getting Q is equal to 1 and Q bar is equal to 0. I think up to this it is very much clear. Okay. Now, next case, in next case we will be having S also 1 and R is also 1, S also 1 and R is also 1. Let us check, if A is equal to 1 and R is also 1. So, by this rule, if any of the input is 1, the output will be 0 of an OR gate. So, Q will be also 0 and Q bar will be also 0, but is it correct? No, Q and Q bar cannot be same, right, it is against the complement rule. So, here this case is invalid. When both the inputs are 1, the output are invalid, because q and q bar getting the same value. This is wrong. And now we will be come to the first case 0 0. I have escaped that, and I have told that I will discuss at the last. So, now we will be discuss about 0 0 condition, when both S and R both are 0. So, if S and R both are 0. So, see sorry, we know if any of the input is high, the output is 0, but if any of the input is low, we cannot say which is the output. We are not sure that what will be the output of this gates. So, we have to assume, suppose in this case, suppose let us assume q is equal to 0. Okay. So, if q is equal to 0, here 0 is coming, 0 0 NOR gate output is 1, and if this 1 is coming to this, so 0 1 will be getting as output 0. Okay. So, here we have considered value of q as 0, and again we are getting output as 0, means the output is retained, present state and next state. We have present state, we are considering q is equal to 0, and next state also we are getting next state as 0, means it is retained. This is the memory concept. This is the memory concept. Now, again you will be say, sir, if we consider q is equal to 1, what will be the output? Let us check. If we considering, if we are considering q is equal to 1, then this 1 will be coming that, and any 0 1, the output will be 0, this 0 will be going to there, 0 0, the output will be 1. So, in this case also, if we have considered q is equal to 1, the next state also we are getting q is equal to 1, means retained, present state and next state both are same. So, this is the nothing but the memory concept. This is nothing but the memory concept. So, this is the final truth table of SR latch using NOR gates. Very important SR latch using NOR gate, and if you design using NAND gate, there will be little bit difference. I am going to write that. This is using SR latch using NOR gate, and this is SR latch using NAND gate. Okay. These both the truth tables are very important. See 0 0, 0 1, 1 0 and 1 1. In this case, we will be having, first will be not valid, then we will be having 1 0, 0 1 and memory. Whatever the steps we have done for NOR gates, you can check from NAND gate, but NAND gate the thing is different. NAND gate, if any of the input is low, then the output will be high. The condition of NAND gate is different. So, according to that you can design the SR latch. So, we can design SR latch using NOR gate or NAND gate, right. So, these are the two truth table. Okay. So, now we will discuss about SR flip flop. So, there will be some drawbacks of SR latch. So, we are going to the SR flip flop. What is the drawback? Because we have told only valid 1, then only it will be output, right. So, SR flip flop are considered sequential logic circuit, as the present output value depend on present and past input and past output. However, in this case flip flop clock signal plays a crucial role, because flip flops are necessarily designed to operate with a clock. Already clock concept I have discussed in the previous slides. So, in this case flip flop, when input is changed from one value to another, then the stored bit changes only when there is a change in the clock. But in SR latch, whenever there is a change in input, the output gets changed. Okay. That means the change in input, the stored information also changes. This is the drawback of SR latch. But in SR flip flop, when clock addition to the input, when clock is also changed, then only the stored bits will be changed. So, this is the basic difference of SR latch and SR flip flop. SR flip flop is designed using SR latch. So, this part you can see, this part is nothing but SR latch, and we are adding 2 more NAND gate. So, 1, 2, 3 and 4. So, total 4 NAND gates are there, but this part is SR latch, and again here we have taken clock signal between these 2 NAND gates. Okay. So, check in the diagram, it is nothing but SR latch plus 2 more NAND gate and having one clock input. Okay. So, let us discuss about the function of SR flip flop. So, first of all we can check this is A star and R star. Okay. For understanding purpose I am renaming this as A star and R star. Okay. A star and R star, and this is S and R. Okay. So, this is SR latch, just now we have discussed this is SR latch. So, we can check the SR latch, this one, this is A star and R star, this will be the truth table for the latch part, not valid 1001 and memory, we will check here, see not used 1001 and memory. Now, using this we will design the S and R. So, S and R 2 variable 4 combinations 0 0, 0 1, 1 0 and 1 1, and clock, if clock is 0 then no need to check S and R. Okay. If clock is 0 there will be no change. Okay. No change means memory, no change means memory. If clock is 1 and S or R 0 0, then check from the previous one. See, clock is 1, S 0, R 0. So, 0 1 NAND gate output is 0, 0 1 NAND gate output is 0. So, 0 0 S star and R star 0 0, what will be the output? S star R star 0 0, then S star and R star, if we will be having, one second, we have just done little mistake. So, here we have written the truth table for AND gate only, 0 1 NAND gate output will be 1, 0 1 NAND gate output will be 1. So, S star and R star both are 1. So, check the truth table, if S star and R star both are 1, the output will be memory. So, here we have written memory. Is it clear? Next, again we will check, this is, we will check like this. Now, S 0 R 1, 0 1 output will be 1, 1 1 output will be 0. So, now S star 1 R star 0. So, what will be the case? S star 1 R star 0, then the output will be 0 1, this case S star 1 R star 0, the output will be 0 1. Like that we will be taking as 1 0, and the last case when both are 1. See, if all are 1, if in this case all are 1, so what will happen? If S is equal to 1, R will equal to 1, then this is also 1, 1 1, the output will be 0, here will be 0. So, S star 0 and R star 0, what will be the final output? S star 0 and R star 0, the final output Q and Q bar will be not used. So, here we will be having not used. Got it? The truth table for SR flip flop. Now, to design SR flip flop, we will check from this truth, this is the truth table, and from this truth table here we will be getting this Q bar. So, now 2 states are there, present state and next state. So, if present state is Qn, the next state will be Qn plus 1. So, with that concept we will be designing final truth table. So, here the same thing will be there, clock 0, the same part of the truth table, the left part will be same, right side will be having only one output as Qn plus 1, that is next state. So, we are being saying as 0 0 cross cross, memory means Qn and Qn plus will be same. So, if I am writing Qn plus 1, here we will be getting as Qn, okay, because memory concept. In second case also, if this is clock 1 0 0, again we are having memory concept. then memory constant means qn plus 1 will be qn. Okay. When 0 1, this case we are having output as 0, this is q, we are actually consider this value only, q bar not, only q value will be considering. So, q will be 0. So, we have written q as 0, then 1 0 case q will be 1, and 1 1 case we are having invalid, not used. So, we have written as invalid. So, this is the final truth table. From final truth table we will be designing characteristic table. You will be saying why we were doing this much of tables, because we have to design the SR flip flop, and this is the most convenient way to solve the design procedure. So, now this is qn and this is qn plus 1, this is present state, this is next state, and S are the 2 inputs. So, qn present state can be 4 conditions, Sn state can be 4 times this 0 0, and for that 4 combination 0 0 0 1 1 0 1 1, and again qn will be 1, and then will be having 4 conditions 0 0 0 1 1 0 1 1. So, let us check from this table we will be going to make this characteristic table. So, when S and R 0 0, qn plus 1 will be 0 0, qn plus 1 will be qn. So, here the value of qn is 0. So, here we will be writing as 0. Now, 0 1, 0 1 case qn plus 1 is 0, 1 0 qn plus 1 is 1, 1 1 this is invalid. So, 0 0 1 invalid. Up to this I think it is clear to you. Now, the next case when S and R 0 0. So, S and R 0 0, qn plus 1 is qn, So, here qn value is 1. So, it will be coming as 1. In this case qn will be 0. So, it will be 0. This is the very most important part of this truth table, right, of this characteristic table. 0 1 again will be having 0, 1 0 will be 1 1, and 1 1 case has having invalid. So, the final truth table is 0 0 1 invalid, 1 0 1 invalid. So, from this table we will be going to do the excitation table, and this is the most important table, excitation table. So, here qn plus 1 0 0 0 1 1 0 and 1 1. Just look at the previous table and you can check it. See 0 0, 1 second. Here qn, again I am just writing here 0 0 1, 0 0 1 invalid, 1 0 1 invalid. Okay. So, in this case just check, we will be going to write the excitation table for SR. See, in this case qn 0, qn plus 1 also 0, again one place this qn 0 and q plus 1 also 0. So, in this case both the cases S is 0, but once R is equal to 1 0 and once R is equal to 1. So, it is fluctuating, S is 0 in both the case, but R is fluctuating. So, we can write like this 0 cross, because one time R is equal to 0, one time is R is equal to 1, then 0 1 for 0 1 combination, see 0 and 1, only one place is like. So, here S or R 1 0. So, we can write as 1 0. Next for 1 0, see 1 here, not this one, 1 and 0. So, we will be having as 0 1, we will be having as 0 1, right, and last 1 1. So, 1 1 where is that? See q n is 1, this case q n plus 1 is also 1, q n 1, q n plus 1 is also 1. Here R is 0 in both the cases, but this case S is 0 and this case S is 1. So, S is fluctuating, R is 0. So, we can write like this cross 0. So, this is the final excitation table, and from this characteristic table, we can draw a K map. Okay. So, K map will be for q n plus 1, this will be q n plus 1. So, the inputs are q n, s and r. So, we can q n, s and r. So, if we put like that, so 0 0 cross 1 1 0 cross and 1. We are just putting the values of this characteristic table into the K map, and if we simplify, one form will be this. So, this will be nothing but S, and this combination it will be q n r bar. So, the final equation of SR flip flop is S plus q n bar. Okay. So, this is the final design of SR flip flop. Thank you.